What's up, math fans? Today we're doing dilations, so I'm still with the geometry guys. Best way I can explain a dilation is you're taking an image and you're changing its size, you're not changing its shape. So it grows or shrinks in proportion. A lot of times I use the phrase dilated pupil when your eye grows, your pupil grows, not your whole eye, your eye doesn't grow that fast. My more favorite example is, you might see this in a movie. It's a bad signal. They shine a light from here onto this shape, which is small enough to hold, and then it grows huge, and they can then see it in the sky. And that is a dilation. This point where the light came from, that's the center of dilation. This is the old image or original image, and this is the new or dilated image. Keep that in mind. So take a look at this triangle right here. You got yourself a triangle. By the way, they only use that signal until the real hero shows up. Now, take an image like this and you see a triangle. If you look carefully, you should see two triangles. I see two triangles, and to make it even clearer, I pull this little one out. There's a little brown triangle right here. It's called ECD, so I pulled it out, and here's ECD right here. And the original large black triangle is ACB, and that's right here. If you look even more carefully, angle C is here. Angle C is also here. So angle C and angle C are the same. And if you look even more carefully, angle B is congruent to angle EDC. These two angles are congruent. So this is congruent to this. So now when I'm comparing these two triangles, the big one and the little one, this congruent, this is congruent. Those are considered corresponding angles. Two pairs of corresponding angles are congruent. I don't even need to discuss that these are also congruent, which they are because they have to add up to 180. But I don't need to discuss that. As long as two pairs of corresponding angles are congruent, that's considered the angle-angle theorem, then I have similar triangles. So as long as an angle is congruent to another angle and the second pair is also congruent, I have similar triangles. And if I have similar triangles, I can use the phrase dilation. One was small, now it's large. Similar triangles is good to know because I use proportions to find missing sides. So you might get a question like this. Solve for x, and they'll put the x. It could really go anywhere. I'm going to put it as the base. In fact, they might not say solve for x. Another way to ask this question is they could just say find BC. And they can even get trickier with you and say instead of find BC, they could say find BD. But there's no way to find BD unless you find BC first. Okay, so our goal is to find, you know what, make it tough, we'll find BD. Okay, first of all, looking at this diagram, ignore that. That was just me separating them so I could see it better. But if you're just looking at this, can you figure out what the center of dilation is? I'm looking at it, I'm looking at it, I'm looking at it. This point C doesn't change. So it takes CE and it dilates it. It takes CD and it dilates it. So if you consider triangle ACD, the original, and you consider triangle, I'm sorry, I made a mistake. Let's try that again. If you consider triangle ECD, the original, and you consider triangle ACB, which is the big one, the image also known as the dilation, then my center of dilation is C, and the constant of dilation comes from a simple formula, the new shape or the image divided by the original. Very, very simple. New over old, image over original. New over old, same thing, image over original. So what do you mean by that, new over old, image over original? Meaning the length of one leg is all you need to know. So here we have, I need the image, the image, the image, the image, the image. The image is ACB, the image is the big one. Do I have any lengths here? I don't. I have, oh wait a minute, look at this. I've got a 10. Let me put that here. So I'm going to say 10 over, give me the length of the original now, or the old. So the original was the small one, here, the brown one. Let's see, I could just put it over 5, right? Right? No. Why not? Because 5 and 10 are not corresponding. Keep in mind the word corresponding. That means the same location. If I'm going to use 10, I have to use the corresponding side to 10, which is 4, not 5. Be careful. Some people just use the easier numbers, and it's not supposed to be that easy. So 10 over 4, or if you want to reduce it, you went to 3rd grade, becomes 5 over 2. So my constant of dilation is 5 over 2. All right? It's a lot easier than I made it. I was just trying to throw some vocabulary at you. It's simple as center of dilation is where the image grows from, and constant of dilation is the new length over the old length. Okay? Clear out this stuff. Now, I'm still trying to solve for x. Still trying to find BC. Here's BC. I got DC. So, I'm going to use a proportion just like I used a ratio. What was it? New over old. Or you could say image over original. Or you could just say big over little. It really doesn't matter how you set up your proportion as long as you stay consistent. So let's say I go with big over little. I'm going to say big base x over little base 5 is equal to, is in proportion with, I gotta use this because this is the only thing I know about this triangle. So 10 of big side over little side, corresponding little side. So that's 4. Here I have a simple proportion, which if you took algebra, you know how to do. Cross multiply. 4 times x is 4x, 10 times 5 is 50. Divide by 4 on both sides, and x equals, let's see, 4 goes into 5 once, with a remainder of 1. 4 goes into 10 twice, so 12.5. Am I done? No, because you asked for BC. Oh, wait a minute, BC is x, so that's 12.5. Oh, wait a minute, no you didn't. You made it complicated. You want BD. Well, BD is 12.5, subtract 5, right? So that's 7.5, done and done. Keep in mind, you need a proportion. You can't simply say, oh, well, this was 4, this was 6. You just added 6 to it. So I'm just going to add 6 to this. 5 plus 6 is 11. It's 11, right? Ha, it's never that simple. Proportions are being multiplied or divided, never added or subtracted. All right? Don't make that mistake. Thanks for watching. See ya.